Let's go through the examples in Chapter 5, 5.1 Functions. Example 1, Paula is working on an environmental project and is analysing the amount of paper used to print some books. She finds out that to print one copy of a certain book 6 meters squared of a particular type of paper is needed. Let A be the set of the number of copies of the book, 1, 2, 3, 4, 5, and B the set of the amount in meters squared of the paper needed to print that number of copies, 6, 12, 18, M and N. Find the values of M and N. Well, A, the answer is M is 24 and N is 30. For every book, 6 meters squared is needed. So for 4 books, it's 4 times 6 is 24 meters squared is needed. And for 5 books, it's 5 times 6 is 30 meters squared is needed. Now the reason we can say that is, what's the relationship between these numbers and these numbers? 1 multiplied by 6 is 6, 2 multiplied by 6 is 12, 3 multiplied by 6 is 18, 4 multiplied by 6 is 24, and 5 multiplied by 6 is 30. B, write down the set of ordered pairs for this relation. Now a set of ordered pairs is your x and your y values normally. That's an ordered pair. Okay, it's a coordinate pair. All right, so R equals 1, 6. We've taken the 1 from here and we've got the 6. So that is the 1 and there's the 6, 1, 6. Next one is 2, 12, 2, 12. 3, 18, 3, 18. 4 is M and that's 24, so it's 4, 24. 5 and N is 30, so it's 5 and 30. Example 2, consider A, this set A, minus 3, minus 2, 0, and 2. And the mapping, using this notation, x maps to 2x squared minus 1. A, find B, the set onto which A is mapped. Okay, so basically, this set here, minus 3, when we put in minus 3 here, that's 2 times minus 3 squared. Minus 3 squared is 9, times 2 is 18. 18 minus 1 is 17. Now that's interesting. These are the work solutions on this side. We have our 17. These are wrong. This should be 17, 7, minus 1 and 7. 17, 7, minus 1 and 7. Those numbers there should be 4 of those numbers. They should be here in the order 17, 7, minus 1 and 7. Okay, let's just test that out. We put a minus 2 in here. We've got 2 times minus 2 squared. Minus 2 squared is 4. 4 times 2 is 8. 8 minus 1 is 7. So that's good. We put a 0 in here. 2 times 0 is 0. Minus 1 is minus 1. And put a 2 in there, and we've got 4. Right? 2 squared is 4. Times 2 is 8. Minus 1 is 7. That's where we've got the 7 here. So this should be 17, 7, minus 1, and 7. B, determine whether or not this mapping is a function from A to B. This mapping is a function, many-to-one function. Every element of A is mapped onto one and only one element of B. The reason they write it's a many-to-one function, not a one-to-one function, but a many-to-one function, is because minus 2 and 2 give the same result. Similar to a parabola. Well, it is a parabola. Okay, that's what's happening. The minus number and the positive number, because it's squared, it's going to have the same result. And that's why it's a many-to-one function. Example 3, consider the function y equals x plus 1 where this is the domain. So x is greater than or equal to minus 2 and less than or equal to 1. Find the image of x equals minus 0.5. Well, to find the image, you just put minus 0.5 in for x. So the image equals, y is the image, equals minus 0.5 plus 1, and the answer is 0.5. Substitute x equals minus 0.5 into the formula of the function, and the answer is 0.5. So the image is the y value. B, write down the domain. Okay, that's the domain there. It's x is greater than or equal to minus 2 and less than or equal to 1. So that's what the domain is. Remember, the domain is the x-axis and the range is the y-axis. In this case, the domain is x is greater than or equal to minus 2 or less than or equal to 1, as given next to the formula in the question. It's given. Example 3, continued. Consider the function y equals x plus 1 where x is greater than or equal to minus 2 and less than or equal to 1. C, use your GDC to help you sketch the graph of this function. Well, here's the answer here. It looks like that. Now, they've done it by using the endpoints. The endpoint, for example, x is minus 2. They put x minus 2 into here. It's minus 2 plus 1. is minus 1, and so they have the point minus 2, minus 1. They have that point. Then they use the other endpoint of the domain here, and that's 1. So they put 1 in here. When x is equal to 1, y is equal to 2, so they know another point, and that's 1, 2. Now, because you're sketching, you just have to put that point and that point. It is a line. It's a straight line, so you can just join the 2 points together, and then you've got it. You can then sketch the graph onto paper, remembering to mark the endpoints. So you don't have to mark the endpoints because it is limited to there. It doesn't go on anymore, and it doesn't go anymore in this direction. The endpoints for this graph are minus 2 and minus 1, and 1 and 2. Of course, another way to graph this would to look at it, and we know y equals mx plus b. When x is 0, y is 1. X is 0, y is 1. There's the point right there. It has a slope of 1. That means it has a rise of 1 and a run of 1. So we could put another point there, and you could just draw it like that. Hence, find the range of this function. When you see the word hence in your exams, you must use the result from the previous question. Okay, hence, find the range. Well, this is what we can use to find the range. If the domain is the x-axis values, the range is the the y-axis values. And so we can see here, the y values go from this point here, which is minus 1, all the way up to 2. So the answer is y is greater than or equal to minus 1 and less than or equal to 2. It's that distance here, because that's the range. They're the only values you can have for y. Once the graph is drawn, you can see its range by squashing or projecting it onto the y-axis. So what they mean is you can squash it onto here, squash that onto there, and you've got minus 1 to 2. The way that you write it is y is greater than or equal to minus 1 and less than or equal to 2, and this notation is good as well. The blue line represents the range of this function, okay, which is y is greater than or equal to minus 1 and less than or equal to 2. That blue line is the range because it's on the y-axis. Example 3. 2. Consider this graph of a relation. Note that if a graph has a solid dot, that dot solid, then this means that the point is included in the graph. If there is a hollow dot, like this one here, which I assume that one is, it's hard to see, then this means that the point is not included in the graph. A, explain why this relation is a function. And the answer, for every input x, there is only one output y. Any vertical line drawn between the endpoints will cut the graph exactly once. This means that every input x is mapped to one and only one output y. This is called the vertical line test. So remember, if you can draw a line straight down and it only cuts the function once, then it's a function. It only cuts the curve once, it's a function. Now it says here, determine its domain and its range. Well, domain's related to the x-axis, range is related to the y-axis. So using this notation is quite clear, right? Domain has got an x here, dot, dot. Now, x's go from minus 2 to 1, but I think it's not including 1. That's actually an open dot, that one. So that means x is greater than or equal to minus 2. We include it because it's a solid dot. And it's less than 1 because that's an open dot. The range is on the y-axis, so it means y is greater than or equal to minus 1, greater than or equal to minus 1, and less than or equal to 3, because both that and that point on the curve are basically, that's a solid dot as well, actually, because it's a point of the curve, and that's the end point, and it's solid, so it includes that. Oh, here's the information here. Project the graph onto the x-axis to see that the domain, the green line, is minus x is greater than or equal to minus 2 and less than or equal to 1. That's a good idea. Project it down to the x-axis, so we just run that straight down to there. It includes minus 2, and it doesn't include 1. That is an open circle there. Observe that x equals 1 is not included in this domain because it's an open dot. Project the graph onto the y-axis to see that the range, the blue line, is y is greater than or equal to minus 1 and less than or equal to 3. So that's quite a good idea to do it that way. Okay, so it's from that point there, and you project this to the y-axis as they suggest. So the range then would be y is greater than or equal to minus 1, because that point's included. Minus 1's included because it's solid, part of the curve. And less than or equal to, because that's a solid dot, 3. Y is greater than or equal to minus 1, less than or equal to 3. Example 4, consider the function x squared plus 1. Find the value of function with 2, right? It's a function with an x there, but now it's a 2. So if that x is now a 2, then that x is a 2, so that would be 2 squared plus 1, and that's 5. To calculate the function at the value of x equals 2, substitute x equals 2 in the formula of the function by replacing x with 2, and you get 5. Find the image of x equals minus 1. Image again is the same. The image is the y value, the function value, the vertical axis value. So when x equals minus 1, you put it in there. That becomes 1 because minus 1 squared is 1. Plus 1 is 2. So the answer is 2. The image of x equals minus 1 is found by replacing x with minus 1. It's the same in the formula of the function. So we put it in there. A table can be drawn in your GDC to find the answers to A and B. Okay, pretty straightforward though. You just put them straight in. C, determine whether the point 526 lies on the graph of the function. The way you find out is that's the x value, that's the y value. If you put a 5 in for x and you put a 26 in for the function, then 26 should equal 5 squared plus 1, which it does, so it must lie on the graph. If the point 526 lies on the graph, then when x equals 5, y equals 26, replacing x in the formula of the function with 5 gives us 26, so y equals 26, and therefore the point 526 lies on the graph of the function f. Example 5, the price in dollars of a motorcycle t years after purchase is modelled by this function, and the domain is limited, it's restricted. T is greater than or equal to 0 and less than or equal to 6. Since t is in years, it's between 0 and 6 years. A, state the independent variable and the dependent variable. The independent variable is t, and the dependent variable is a function, p, the price of the motorcycle. Remember, the independent variable is always the x one. What we'd normally see is x on the right-hand side, and on the left-hand side is the function, and that's the dependent variable. The coordinate pairs in this relation are of the form t and the function. The first coordinate is the independent variable, the second is the dependent variable. B, find the value of the function when t equals 0. State the meaning of that function when t equals 0 in this context. Well, you put 0 in for t, and it becomes 15,000, doesn't it? Because that term becomes 0. So p, where t is equal to 0, is 15,000. And p, where t is equal to 0, represents the price of the motorcycle at purchase. It's the initial price. Substitute t equals 0 into the formula for p, and you get 15,000, and that's how they got that. Example 5, again, it's the same example, but this is C, right? Same information here. Find the price of the motorcycle 1.5 years after purchase. Well, you just put 1.5 for t, and that would be 15,000 minus 2,500 times 1.5, and the answer is 11,250. Substitute t equals 1.5 into the formula, and you have something like that. Make sure you write it out like that. You'll get a point for that, and there's your $11,250 there. D, find the value of t for which the function equals 6,250, which means the value of the motorcycle is 6,250. Interpret this value of t. So the answer is t equals 3.5. After 3.5 years, the value of the motorcycle is 6,250. And the way we need to find the value of t for this is that the function is 6250, so that means that this left-hand side is 6250. They've done it backwards here, but it doesn't matter. They've put the left-hand side on the right-hand side, 6250, and this part is on the left-hand side, and then you solve for t. Using algebra, t equals 3.5 years. Here we are, the last few questions that are related to example 5. It's the same question. E, comment on the case of t equals 6. Well, all you do is you put in the function. You want to find the function value where t equals 6. So the price of the motorcycle is $0. And why is that? Because when you put t equals 6, you've got 15,000 minus 2,500 times 6. Well, that equals 0. So therefore, the motorcycle value is 0. F, sketch the graph of this function. Well, now we have to graph it. Well, we know what it is at 0. It was 15,000. And now we know what it is at 6. It's 0. It's a linear function because the t is not squared or cubed. It's just a t, right? And it's on the numerator, it's at the top. So basically, it's just a straight line, and it's a negative slope because as the years progress, the value of the motorcycle drops. Okay, and this information here, it says plot the graph. So we've plotted it there on your GDC. To do so, replace the independent variable of x and the dependent variable of y. Recall that the domain is between 0 and 6. That's the answer. Label the axis and indicate some scale when you copy the graph. Mark the axis intercept. You need to put that point in and that point. You could write them as a coordinate pair. Put that down as 6, 0, and this one is 0, 15,000. You could also recognize this as y equals mx plus b, and you can see that b is 15,000, so it crosses, that's a y-intercept, 15,000.